All right, everybody, welcome to the video here for lesson number 8 on factoring trinomials. So we reviewed a concept that we actually learned about way back in um, our Algebra 1 classes. So a couple things, as soon as we see factoring completely, we know that we're looking to factor all the way down as much as possible. Also, we always want to look for a GCF. Sometimes it just makes the numbers easier to manipulate and use. Sometimes you can factor without taking the GCF, but it just might take a little bit more thinking. So let's start with this first one. So first thing I notice is there is a GCF. So if I divide out a 6 goes into 48, does it go into 90? It does, 6. So I have x squared plus 8x plus 6 goes into 90. 15 times. So then it just becomes regular trinomial factoring. So we got to figure out what multiplies to make 15, adds to make 8. And those numbers would be 5 and 3. So we'd say this is 6, x plus 5, and x plus 3. Notice using GCF there first really helped us a lot. The next one does not have a GCF. So we have to use the AC method. So it multiplies to make negative 60, adds to make 4. Now, if you're having trouble with the mental math part of this, just plug into your calculator y equals negative 60 over x, and look in your table of values. You'll have all the different matching pairs that multiply to make negative 60. Now, if you keep going through there, you'll see that negative 6 and positive 10 are my pair. So I'm going to break apart 4. So I'm going to say 3x squared minus 6x plus 10x minus 20. How we break this up doesn't matter as long as it's those two numbers. So like if I put 10 first and negative 6 second, it would be fine. So if we go through, make our two groups, we can say 3x, x minus 2, plus 10, x minus 2. Notice my two parentheses are the same. They're a like term or a GCF. So if I divide out that GCF, x minus 2, I would be left with 3x plus 10. Something I might not have mentioned in class, if you want to check really quick that you did it right, you can always multiply this out. You should get back to this original expression. All right, let's keep going. So we see 4, 25, 25, no GCF, so we got to use that AC method again. So we want to try and figure out what multiplies to make 100, but adds to make 25. How about 20 and 5? So if I break that apart, I have 4t squared plus 20t plus 5t plus 25. Let's take a look. Two groups. 4t, GCF, leave me with t plus 5, plus 5 GCF, leaving me with t plus 5. Yay, we have the same thing. So because we have the same thing, we know that there is a common term. Divide out the GCF again. For that fourth one, we see x cubed, but it's a 3-term polynomial, so we can't use difference or sum of 2 cubes, but we do notice there's a GCF. X is in all 3 of these. Then ignore that the x is there, it's just going to be in my answer. And then we're trying to figure out, well, what multiplies to make 40, adds to make negative 41, negative 40, and negative 1. So I'm going to break this apart. Now notice I'm putting all of this in one big parenthesis so that it stays where it's supposed to. We don't forget about x then that way, right? So we have that x there at my answer. So GCF is 5x, leaving me with x minus 8, negative 1, x minus 8. So my final answer is x, 5x minus 1, and x minus 8. Next, we have a GCF. Biggest number that goes in all 3 of those things is 4. Leave me with 2m squared plus 5m minus 3. What multiplies to make negative 6, but adds to make 5. So that'll be 6 and negative 1. So we can put the 4 outside again. So we have 2m squared plus 6m minus m minus 3. Divide this up. We have 2m. We have m plus 3. negative 1, we have m plus 3. So we have 4, 2m minus 1, m plus 3. All right, lastly, we have something to the fourth power. Now, we haven't seen that in class, but you actually did see this in Algebra 1. So when we do this factoring method, we just have to remember that we're breaking it down into an x squared and an x squared instead of an x and an x like you did here, or in this case, m and m. So same thing, AC method. So what multiplies to make negative 36, but adds to make positive 35. So that would be positive 36 and negative 1. So when I break this up, I'm going to have 9x to the fourth plus 36x squared. Remember, I'm breaking up this term, so that expression of x squared is going to be there. Minus x squared minus 4. So what do we get? 9x to the second, x to the second plus 4. I have negative 1, x to the second plus 4. So now we get 9x squared minus 1, x squared plus 4. The x squared plus 4 is unfactorable, but the 9x squared minus 1 is factorable. So we have 3x plus 1 and 3x minus 1. And the remaining polynomial is x squared plus 4. Nothing left to do there. That's it. Hopefully you had a lot of these right, or maybe any of the little mistakes you made, we fixed them up. So good luck with your homework, and I will see you all tomorrow in class. Have a good night.